So depending who you talk to, low anemia usually is the low number of anemia is blood. Anemia means without blood, basically, right? So now we gotta figure out why she's anemic. So give me some reasons this girl is anemic.
Diet.
All right. So we have the poor diet problem. What in her diet is the problem besides her diet? Low iron. So the doctor's going to bill you for iron deficient anemia. What word is that? I don't know what that word is. So you're anemic because you don't have iron. Iron's used to make blood cells. So if I don't have iron, I can't make blood. Okay, what else might be wrong with this girl that would make her anemic?
Heavy menstruation.
Heavy menstruation is blood loss. Your doctor's going to bill you for hemorrhagic anemia. The blood's on the floor, it's not in you. Therefore, you're running out of blood. Right? Yes?
How could a 96-pound girl still have a heavy menstrual cycle?
That's why we're going to have the gynecology question.
Okay.
That does seem odd, right?
Yes.
Right. What other ways could you be anemic? These are the two that affect our girl. There are others. You learned one in Biology 112.
Sickle cell?
Sickle cell. Because the last word on sickle cell is always sickle cell anemia. Right? So remind me from Biology 112 what sickle cell is. Right, it's the adaptation of malaria. The cells sickle, and what do they do after they sickle? They travel, plug, and then die, right? So if my cells are dying faster than I can make them, I'm going to be anemic. Right? Keep going. How about vitamin D? Vitamin B12 deficiency. Vitamin B12 is used to make blood. Your doctor is going to bill you for pernicious anemia. Yeah. So low vitamins. Then there's one more you can do, which is having hypertension. That's high blood pressure, right? Why would high blood pressure make you anemic? What do you think your blood cells do if you beat them really hard? They die. So your pressure goes up and up, the cells die quicker, therefore you leave the low number. All right? The main two affecting our girl are these two. So she has poor diet, and she's losing blood. Together, those are going to make her lose blood cells and not make more. Make sense? So tell me about her dietary inclusion. Future dietitians, what should she eat?
Steak.
Steak, yeah!
Liver.
Not so yeah, okay. Greens. Maybe nuts. Things that have, so basically red and green, right? Meats and greens. So things that have iron in them. You think about a 14-year-old girl who's watching her weight, I doubt she's eating steak, I doubt she's eating salad, right? So that's the problem. So tell me why you're going to see the gynecologist with this problem.
Severely heavy menstruation.
Right, we have this problem of a menstrual flow at a 96-pound 14-year-old, right? So there might be something wrong why she's bleeding so much. So you want to stop the bleeding. Because we have the problem with her eating, appetite was marginal. The problem with her bleeding, so you got to address both parts, what she's eating, what she's bleeding, right, for this to work. Make sense? So tell me about number 6. You can't see in the book. Why is there a difference between iron in the plasma and iron in the blood? I'm sorry, the bone. There was iron in the plasma, but there was none in the bone marrow. What does that tell you?
Can dietary iron get into plasma?
Yes.
She doesn't have any savings?
Close. You're close.
So dietary iron can get in the plasma, but
Yes.
she's eating some food
Right.
that has some iron in it. So
Right, but that should be in the bone marrow. So why does her bone marrow have no iron?
Because it gave it all the blood.
That's exactly right. Her bone marrow is already made all the. It's already made all the RBCs it can. It used up the iron to make all the cells. There's no more left to make more cells. So all the iron she had has already been converted into a red blood cell because she's not eating enough and she's bleeding. If there was iron in her bone marrow, that'd mean her bone marrow is not making them fast enough. But here the bone marrow made them so fast it used up all its iron. So if you're anemic, your doctor may check where the iron is to figure out if it's a problem with the bone marrow or problem with the other parts. Make sense? So her bone marrow has used up all the iron it has. There's no more left. It's all gone. Make sense? So this poor girl is not making her blood cells. Turn the page. This is a very different situation. This is Michael. One day, parents freak out that he's yellow. Tell me what you call yellow people.
Jaundice.
Jaundice. Very good. Jaundice is your yellow. Okay. Why are you yellow? Very good. Increase in bilirubin. So jaundice is directly caused by an increase in bilirubin. Now we got to figure out what bilirubin has to do with blood. So we're going to make a little graph over here, a little diagram. I have some old RBCs, old bad old blood. Where am I going to send them to get rid of them? Where do you send blood cells to die? The liver. I send the blood to my liver. Why not? What's your liver going to do? Glad you asked. The liver is going to take the hemoglobin out of your cells. My liver is going to take the hemoglobin. And tell me what's in hemoglobin again? There's iron and other stuff. So what do you think your liver wants to do with that iron part? Recycle it. So I'm going to take the hemoglobin and split it into two. The iron is part of it, and everything else is over here. So your liver takes the iron out of the hemoglobin, and where do you think your liver wants to send that iron? To the bone marrow. So your body's going to recycle the iron out of your old blood so you can build new blood out of it. That's kind of cool, right? What are you going to do with all that other stuff that you don't really want to keep?
Take to the spleen.
No, you can take the spleen, but in this case you won't.
You're kidding?
Nope. You're going to turn it into bilirubin. So you're going to make bilirubin out of the old crud you don't want. So bilirubin is a waste product from breaking down old blood, right, from the liver. So I'm going to show you a picture of this, and we'll add the detail in a minute. I lost my liver. There we go. So here's a bone. Remember, bones make blood. So that's a femur. It's making my blood cells. Okay, blood doesn't live forever. Gee whiz trivia, they live about 4 months or so, and they just get old and die, like all of us. So someday you're going to have old blood cells, and your body's going to send them to Mr. Liver. The liver's job is to get rid of that old blood. So it's going to take the blood, take the cells, split them, take the hemoglobin, which is the protein, out, take that and split it again into the iron. The iron you can send back to the bone marrow. I can reduce, reuse, recycle. The other stuff, you're going to convert into bilirubin right there. All right, so bilirubin is a waste product from splitting the old cells apart. Yes?
What's the other stuff?
It's basically the amino acid component. So you take the heme group out, and everything else in the protein, which would be the amino acids, you basically break those up and make bilirubin out of that. So what are you going to do with this bilirubin? Where does stuff in your liver eventually go? It goes in your bile. Yes, it does. The bile ends up where? In my intestines, which are right here. And where do intestines eventually go? In your colon. Where does your colon eventually go? In the toilet. Very good. So bilirubin's eventually going to go in your bile, to your intestines, to the toilet. So once I take the iron out, I'm going to basically poop everything else. That's a scientific word, you know. All right?
Why do babies get jaundice?
Good question. We'll get that. Just stop. Hold that thought for a second.
Sorry.
So this is the normal breakdown. So our person, Mr. Michael, in our case study, he had high bilirubin. Can anyone guess why he might have high bilirubin? Why would anyone have high bilirubin? Something is wrong between what and what?
Just red blood cells and liver.
So it could be something wrong with your liver, that you can't excrete the bilirubin, or it could be something wrong in your bile or your intestines, right? If I can't get the bilirubin out, it's going to build up in my body, right? So it could be a problem anywhere in this system between liver and your toilet. Right? So let's answer the question number 2 then. What's the primary organ for removing old blood cells? The liver. The liver normally does that. Number 3, list the steps. That's on the board. Right? So you take it to liver, split off the iron, take everything else to bilirubin, and flush that down the toilet. So this is the steps. These are the steps. All right? All right. So now let's go through why the sclera is what you see. Why is it you can see in the eyes first? It's not a biology question. Because they're white. It's easy to see yellow on a white background. Right? What other place in your body could you easily see yellowing? Besides the eyes.
Nails.
Under the fingernails, right? Inside the mouth, places where it's easy to see a contrast. It's really hard to see other places. So you're going to see it's places where there's a contrast, like the eyes. Then we're going to tell Martin and Kim to put the baby in sunlight. What does sunlight do to bilirubin? It breaks it down. So sunlight can destroy bilirubin. It doesn't solve the problem, it just gets rid of the bilirubin. They call them Billy Lights at your hospital. You put the baby under sunlight and the baby magically stops being yellow. Right? So why do babies get this all the time, and hopefully you don't? What does that tell you about the baby?
They're not exhausted.
They're not outside. What else?
The liver doesn't work very
The
well.
liver doesn't work yet. So when you're born, have you pooped yet? Hopefully not. Has your liver come on yet? Probably not. So hence you have all these old blood cells that have never been excreted. So you're likely to have bilirubin building up in your tissues. And then you're going to poop a bunch when you get home, and then that will get rid of the bilirubin. Right? So babies, especially prenatals, oftentimes are jaundiced because they haven't turned on this system yet. You're not clearing the blood out. Yeah.
Is that what causes the black tar?
That's not so much this, but yeah, that could be part of it. Bilirubin's a light tan. It wouldn't be the meconium stuff. So when my son was born, he was yellow. And the nurses are trying to educate me. It's like, I know this, right? I'll bring him back in a week if there's a problem. And he's fine in 3 days. So once you go home, you poop a bunch, and eventually you become less and less yellow. Right? Didn't freak me out too bad. Make sense? Right. So babies are usually yellow because they haven't done this. So what happens if you see an adult who's yellow? What's that tell you?
They have liver
Their
damage.
liver's not working. So who becomes jaundice? Alcoholics, because their liver's shot. Therefore, your liver can't move the bilirubin, and this system breaks down, and the old blood cells just stay in your blood and make you a drunk who's yellow. Right? So cirrhosis, hepatitis. So grown-ups who are yellow, bad. Babies who are yellow, it depends. Right? So if you're turning yellow, your liver's on its way out. That's the system that should be clearing the blood out. Make
Could
sense?
liver be a problem with your red blood cells dying off too quickly?
You can end up with jaundice anytime the rate of destruction beats the rate of removal.
Okay.
So you can have bilirubin like if you end up with you'll see sometimes in athletes where they do a lot of strenuous activity, the high blood pressure kills their cells, they'll be slightly jaundic for the next couple of days, but it should go away.
Okay.
If it doesn't go away, then there's a more permanent problem. So our girl case study was she couldn't make the blood. Michael's having a problem getting the old blood out. Those are the two problems.
Is the yellowing of malaria having?
Yeah, because in malaria, the plasmodium destroys all your blood cells at once. So you get this huge wave of old cells, bilirubin skyrockets, and that's why you die, basically. Right. Make sense? Yeah, so malaria actually really, really does take out your blood fast. So again, making blood and getting rid of blood. Cool. So now you have to know about blood typing. Yay. In lab next